In today's session, we will take a look at what is data warehousing and data lake. Because if you say you are a Power BI developer, you should be knowing the data warehouse concepts. Data, what is, or at least you should be knowing what is data warehouse, what is data lake. Nowadays, almost all the companies they started using data lake, and also you should be knowing star schema and snowflake schema. We'll cover that also in today's session, and followed by that, we will take a look at the different types of relationship. So the star schema and snowflake schema, these two are part of your data warehousing. So data warehousing is something like a container, so wherein we store the historical data. To store the historical data, we need to have the table. So just you cannot have tables created arbitrarily. Instead, you need to design the tables. Like I discussed in the last session, normalization rule one, rule two, rule three. Okay, if a table has to be in the normal form, it has to follow or satisfy rule one, rule two, rule three. And we have something else called Boy's Code normalization form, that is advanced one. But all those normalization related to data model, we do it as part of RDBMS database. RDBMS, Relational Database, RDBMS, Relational Database Management System. Okay, the Relational Database Management System is nothing but our database. For example, in our case, we are using Microsoft SQL Server. Now, as part of this training program, I am covering this one. So it is an RDBMS. So within this, there are two different branches. One is OLTP and other one is data warehousing. You can create database for OLTP. OLTP stands for online transaction processing system. Okay, and this is meant for storing your application data, front-end application data, or for example, Amazon website, e-commerce website, Flipkart, Target, all the e-commerce website, they have, right? So they capture the data, all the orders will be raised via their e-commerce website, and those orders will get stored in an OLTP database. The database name can be anything, but it falls under the category of OLTP, online transaction processing. In the case of OLTP, we don't store the historical data. We don't store 5 years or 10 years of data. The more the data you store, it will impact the performance. For example, you want to order two products in Amazon website, and it should be pretty faster. If it takes half an hour, 30 minutes, or more than 30 minutes to raise a simple one order, it leads to customer dissatisfaction. They will be frustrated. So why to order two products, it takes 30 minutes or 40 minutes. Better I will go and order it somewhere else. They will walk out. Hence, when it comes to OLTP, the speed should be very, very faster. Okay, and also multiple users are accessing the e-commerce website across the globe with different time zones, right? So the ends it should support concurrency. OLTP will support concurrency, and here the latency is very less. Okay, latency is the delay. Delay is not accepted here in this case. But our user should be able to raise an order. They should be modify the order, or they should be able to cancel the order. Everything should happen in a pretty fast manner. In case of any delay, what happen is obviously the customer will walk out. So they are in a hurry to order some products, or while they drive the car in the signal, they might have a hardly few minutes or seconds. They want to order it within that time, right? If it takes longer time, what do they lose? They will lose patience, and then they'll walk out of your website and they'll go and check out from other website. Hence, the OLTP is designed in such a way to take care of the concurrency. Concurrently, many users can access the data simultaneously. They should be able to read, write, update, delete the data. Okay, and also response time should be faster. Okay, so that is what that's the purpose of OLTP, and also it is not an historical data. Here we don't store the huge volume of data. If you store more volume of data, obviously it will take longer time to cater to the needs of the customer or respond to the customers. Okay, so that's when, see, if you want to do any analytics, one is to business purpose, to store all the order related data, shipment related data, everything in OLTP system. The next one is data warehousing. If you want to perform any analytics, you need to have the data, historical data. So in that kind of situation, we create a database in the RDBMS software. Using this RDBMS, we create a database. Even for OLTP, we have to create a database, and data warehousing also we have to create a database. But the difference is, in the case of data warehousing database, we store close to 5 years or 8 years data, 8 years or 10 years data worth of data we store it. So only then, if you store many years of data here, you can compare the performance, okay, the sales performance, revenue performance, net margin, everything. You can compare last 5 years sales, last 8 year revenue across the category, across the location or regions, right? You can do it. So data warehousing is nothing but a central repository. See, it's a centralized repository of well-structured data gathered from diverse sources. Okay, so in this case, one OLTP. Likewise, you have multiple OLTP systems are there. So all these OLTP system data, different source system data will get stored into this data warehouse. Okay, so data gathered from different sources. In simple term, the data has already been clustered and categorized and is stored in complex tables. So before we load the data into data warehouse, we clean the data, and then we categorize and store the data in the fact table. We have something called fact table, dimension tables, and so on. So if somebody is asking you what is data warehouse consists of historical data, not only historical, and also it has a time variant data in it. Time variant data in it. So what do you mean by time variant? Time variant is the historical data is kept in this data warehouse. Okay, so if you want to retrieve data from 3 months, 6 months, 12 months, or even older data from the data warehouse, okay, that is possible. Okay, this contrasts with the OLTP system. Okay, so the data warehouse is integrated. That means, different source system. We pull the data, and using the ETL process, we extract the data, transform the data, which is nothing but cleaning the data, categorize the data, and then load the data into data warehouse. So here we integrate different source system data. Okay, and then historical data. We store the historical data, and once you store the historical data, it will not undergo any changes. It is non-volatile. Nowadays, you're not going to make any changes. Okay, rarely you are going to make changes to your data warehouse database, because the in the data warehouse you have huge, let's say 1 petabyte volume of data is there. Okay, and the fact table. In that case, if you are going to make an update, it will take a lot of time. The update, delete, if you do any update or delete operations, it will be very slow against a huge volume of table. Okay, so data warehousing is integrated one, and it will consist of the historical data, and it should be non-volatile. It should not undergo any changes or any major changes, and also it is a time variant. Time variant, as I discussed a while back, you can, once you store the historical data, you can perform like for like analysis, like year-on-year sales, quarter-on-quarter sales comparison. You can do it if you store the data with the date. Next, we will understand what is a data lake and what is the difference between data warehouse and data lake. So data lake is a centralized repository like a data warehouse, but it allows us to store all our structured and unstructured data at any scale. Okay, you can store the data as it is. See, you have source system data, simply EL, we perform EL, extract and load the data. But in the case of data warehouse, we extract the data and then we transform the data and then only we load. 1, 2, 3, three steps are there. We carry out these three steps. But when it comes to data lake, we simply pull the data from the source system and then load it into our data lake. So Azure, they have their own data lake. They call it as a Azure data lake. Okay. So, and then here, and then only the transform happens. See here, the step 1 and 3 of data warehouse happens. Here, the step 1 and step 3 is happening in the case of data lake, and the step 2 is happening at the end. So why only extract and load here? The reason is, let's say in my company, I have hundreds of source system databases or files are there. So I take the data, extract the data from all the source system, and then I will load it here. The reason why I extract and load it here is, I don't want to do any transformation while extracting the data. When you extract the data, if you do any data transformation, for example, you want to join 10 weeks sales data, and then you want to do some kind of left outer join, right outer join, and then you want to do some kind of union, and then you want to do some kind of complex transformation, aggregation, everything. If you do it, what will happen is all these transformation, if you do it while extracting the data from the source system, this transformation will happen on the source system itself. It will literally slow down the source system performance. My source system is an e-commerce. It is holding e-commerce data. People across the globe, they are accessing my database behind the scene via our e-commerce application. Already it is overloaded with so many transactions. Customers are keep ordering, and there are some customers, they are modifying their order. Some customers, they are canceling the order. Everything should happen parallelly, that too in a very fast manner. There should not be much delay here. Already we are, lot of users are accessing this database concurrently. On top, just because for my analytics purpose, if I extract 100 tables, and if I join to 10 or 15 tables, what will happen is it will slow down the source system performance. Okay, so what we do is we simply extract the data that are relevant to our analytics, and then we load it into our, and then what we do is we do transformation. Okay, it is something like you buy a vegetables from the shop, and then you keep it in your kitchen. Later on, what you do is your vegetable, meat, everything you kept it here. Later on, what you do is you cut the meat and clean it, and you do everything after you brought it from your shop, right? So, for example, in this case, take away fish, right? If you are buying a fish in the market, and if you are asking themselves to clean it and wash it, everything, it take longer time, right? It requires wait time. You have to wait in the queue, and and then they will cut your fish, and then they will clean it. That takes time. Instead, what to do is simply buy the raw one and put it here in your kitchen, and then you clean it. The same principle is applicable here. Here, if you extract the data and load it, there is no wait time, nothing. Fat, it will happen, right? But here in this case, what we do is we extract the data, and then we transform the data, and then we load the data and load. So here also, what we do is, logically speaking, we don't put the burden on the source system by performing the data transformation while extracting the data itself. Instead, we use something called staging database. Okay. See, in the data warehouse database itself, there are two things. One is one is for data warehouse, other one is for staging. The staging, we do it everything here. So logically, right? So this is the data lake fits in here. So extract the data and then load the data. So this kind of a staging area. From the staging area, we perform the data and then load the data into my data warehouse. So Azure Data Lake is very popular in the Microsoft cloud platform. So now the question is, why should I need a data warehouse? Okay, so don't get confused with data lake and data warehouse. Data warehouse is to store the data permanently, the historical data, whereas the The data lake is to store the data temporarily there. All the resource system data, we store it there. Temporarily, we park it there. And then only we do the data transformation. Once we clean the data and we merge the data and you do whatever aggregation you want it on top of the data and you do it, and then you load the data in data warehouse. Once you load the data in data warehouse, your data will be clean, pre-processed. It doesn't require too much of data transformation. Even after this, we do some kind of transformation that is related to our analytics business logic. Okay, not the complete data cleaning, all the things, we don't do it here. Okay, so we understood the difference between data lake and the data warehouse. Okay, when it comes to data warehouse, to model the data, we use a technique called dimensional data modeling. We use a technique called dimensional data modeling. In the case of data warehouse, to model the data, we use a technique called dimensional data modeling. Let me check if this is being recorded or not. Okay, dimensional data modeling. Okay, and so when it comes to OLTP, last session we discussed about normalization. We do the normalization. As a data analyst, you don't have to do normalization and all. But in the case of data warehouse, it's a OLTP normalization. Data warehouse, dimensional data modeling. So it is also called as a denormalization. Denormalization. Here, in the case of data warehouse, all the normalized tables, we denormalize it. What do you mean by normalized table? You need to denormalize it. For example, I have a customer table is there in my OLTP system. Customer table, and here the customer ID and the name, and then his address ID will be there. The customer table itself got splitted into two different tables. Here add ID and his address and city, name, everything will be there. To store a single customer information, you need to have two tables in the case of OLTP because of the normalization. But when it comes to denormalization, what they say, why you need to have multiple tables? If possible, try to reduce the total number of tables by combining them into a single table, or try to reduce the number of tables so that we can avoid joining too many tables. Joining too many tables will take a lot of time. It will have a serious performance issues especially when if the data volume is very high. Nowadays, we are dealing with huge volume of data. So that is the reason why there is a, principle called denormalization. When it comes to data warehouse, we try to combine the tables, as less as possible, so that the joins to the tables are very less. Okay, got it. So now the denormalization is also called as dimensional data modeling. Okay, so there are two types of dimensional data modeling we can do. One is the star schema, other one is snowflake schema. The star schema is the one recommended by Microsoft also. This is the best practice according to the Microsoft. And Snowflake is also good, but it is not advisable. So here, even in the case of Snowflake, look here, the single dimension, we see all these three are, you can combine into a single dimension. But here, even in the case of the dimensional modeling, as part of the Snowflake schema, we did some kind of normalization. We splitted a single table into three different tables. So here, obviously, you need to join these three tables. Supposing I wanted to know all the products that belong to the corresponding category and subcategory. If you wanted to see that, so I have to join these three tables. Okay, but when it comes to star schema, don't store the data in three, or don't split up the same table data into three different tables. Instead, you store it in a single table. Combine all the columns and put it in a single table. Okay, so that is what, in simple term, that is what the difference between star schema and the snowflake schema. The idea of the star schema is to keep all numeric values in a separate tables called fact table. All numeric quantitative variables, and put all descriptive information to other tables called dimension tables. See, look here, this the fact table is surrounded by many dimension tables. Since this fact table is surrounded by the dimension tables, it looks like a star, hence they call it a star schema. Okay, usually the fact tables are surrounded by dimension. These dimensions explain those facts. For example, here I have something called 10 and 863.23 and 17.2 percentage. If I have something like this, if I ask you what is 10, what is it, can you tell? You cannot tell, right? These dimension tables can allow us to add context to this numerical values. So since these dimension tables have descriptive information in it, we will get to know, oh, this is a quantity, right? So quantity is 10. So for which product? For product A, under category appliances, we sold 10 units and so on so date in north region. We sold it, and this is the sale we made it. This is the profit percentage with the help of dimension, because these dimension tables will hold the descriptive information in it. Okay, in the dimension table, you will have something called primary key. That primary key is nothing but surrogate key column, using which you can uniquely identify the records. And each dimension table in general, we store the records, we store the unique records. For example, for example, you have something called hammam soap. Hammam soap. They have some code H01. The product ID or product key and product name, and unit price will be there here, something like that, or cost price, something like that. Okay. And these information, for example, once you store H01, this is your surrogate key. Okay. You cannot repeat the same thing again. You cannot store so you'll have to store each product only once. Similarly, each category you need to store only once. There should not be any duplicate and so on. Okay. The same thing is applicable here and here also. So with the help of the dimension table, we can answer questions like in so and so, in which quarter or in which month, under which category and which product, in which region, how much we sold, and also by which employee, salesperson, right, is instrumental in selling this or generating this revenue, right? To answer to these business questions, you need to have these dimension tables. The fact tables will have fact in it. What is fact? Nothing but the numeric values or quantitative values, like quantity and sales and margin, something like that. Okay, these are called your, what is it? These are called your measures, or it is called as a fact. Okay, so the fact table consists of not only the numeric values, along with this, the combination of all these dimensions key values. For example, your category key, and product key, and employee key, and region key. Only then you can create a relationship, right? If you don't have these key for these dimension tables, how you can create a relationship between all these tables? That's not possible. So the fact table consists of the combination of all the dimension tables key columns. Along with that, the fact values get stored here, or the measures get stored here. The same thing is applicable here also. The only difference is, look at the same table, the product dimension is splitted into, we did some kind of normalization. We split into 3 different tables. For example, if you wanted to know at the, what is it? Yeah, at the category level, right? So if you want to get into the granular level, right? Which product we sold it. So you need to drill down to subcategory, and then you need to drill down to product. Okay, so you need to join these 3 tables to answer to that question. Okay, it's kind of a drill app. Currently, you are viewing the number of categories and what is the total sales we made. Okay, but the category table has no direct relationship with fact table. Okay, so you need to join all these tables. Only then you can get category level how much sales we made in each category. And if you wanted to drill down, okay, subcategory wise how much we made, and each subcategory what products we sold. You need to join these three tables. If the volume of the data is very high, it takes longer time. In the case of, for example, Amazon and all the retail giants, they they listed out 1 billion products on their website, right? They sell it under a lot of categories and subcategories. In that case, it will take a lot of time to join these tables and takes a longer time. Hence, the star schema is the best one. But understand the difference between star schema and snowflake schema. The snowflake schema is just an extension to the star schema, meaning if you see here, the dimension table is not, see this dimension table is not directly linked to the fact table, right? It is linked to another other two dimension tables, right? Indirectly. Right? So that is the thing you need to remember it. Okay, now the question is, since the snowflake schema is not recommended when, then why they came up with snowflake schema? Okay, the advantage of the snowflake schema is it uses smaller disk space. It uses smaller disk space. See here, you might be wondering, what do you mean by smaller disk space? If you store everything in, let's say, here in this table, okay, I don't have space here. I will just write it. So dim product. The dim product, if I store everything, for example, category ID and category name, and then product ID or subcategory ID, subcat ID, and subcategory name, cat name. Okay, so many columns will be there, and also you have the product ID and product name, and then product price, everything. So your category is C001, category is appliances, and then subcategory ideas, something like appliances like electronics is some ID and electronics, and then the product ID is P001, and electronics item is something like tell me something like camcorder, something like that. Okay, camcorder. And again, C001 category, appliances, electronics. But here, let's say you have something else called mm, apparel. You have something called not appliances, apparel. In the apparel, the subcategory is jeans, and then you need to have something called jeans G01 and which brand, all the things. So if you see here, the appliances or apparels, you need to unnecessarily store it like anything, right? And even the subcategory, you also need to store it for each and every product. You have 1 billion product, 1 billion product for each and every product, right? You need to specify everything in a single thing. Rather, when you use this kind of model, what you do is, so when you use this kind of model, what you do is you store only product relationship here and subcategory relation data here and only category related data here. But here category ID and category ID will get linked, and here the subcategory and subcategory in the product will get linked here. Okay, so in that case, what will happen is the data storage, you don't have to store all the data in a single file like here we do it. So that is the advantage of Snowflake schema. On a case-to-case basis, you will have to use Snowflake schema or star schema. We cannot generalize always star schema is great. Okay, though Microsoft recommends star schema is good one, but still on a case-to-case basis, the volume of the data is very huge. If that takes a lot of space and all, right, redundant space, better you can go for Snowflake schema. But it is easier to implement a dimension, right? It is added to the schema due to multiple tables. But due to multiple tables, the disadvantage is the query performance is reduced. That is one disadvantage with this one. That's all. Okay. So dimensional data modeling, this is a customer dimension, order fact table. So all these are fact table. In the fact table, we can see the consists of all the keys. All the keys. So combination of keys and the facts or the measures. That is what your fact table will have it. Whereas the dimension tables will have the descriptive information about so customer key, first name, last name, those kind of things. That's all here. But here the customer key is called surrogate key. It is a primary key, unique key. This key should not be repeated more than once. That is what I'm trying to say, surrogate key. So dimension tables will have the combination surrogate key and the descriptive information about these facts. Got it? That is what your dimensional modeling. Now you got a fair amount of idea about what is a data warehousing, what is a data lake, and in the data warehouse, how we store the data. So we use dimensional data modeling to design or to model the data, and then only we store the data into it. Okay. So next one is we will understand. Next, we will go ahead and see the types of relationship.